Assalamualaikum warahmatullahi wabarakatuh, and good morning to all my students. Okay, so this is our final lecture for this semester. Okay, for specifically this video is last final recall topic for this semester, and I do hope that all of you get ready for your final examinations. Okay, so now please refer to your lecture notes. Okay, so if you see that all this instruction, or we call the strategy, is the instruction for us, reference for us to how are we going to answer this kind of questions. Okay, so draw a diagram, label the parts imported in the problem. Actually, that we taking all this, okay, the imported in the problems, we are taking out all the information from the questions, write equation for the quantity, and then you can see that we call the step that here to find the f prime, and f prime is 0, and then f double prime for that. We call to see this maximum or minimum. Okay, so then okay, so right now let's see the solution for this question. Okay, I mentioned the question here now. Find two positive numbers. Two positive numbers with the sum is 30 and the product is maximum. Okay, so first we look at the information given here, where two positive numbers, we imagine that we call it is x plus y, which the sum, okay, sum which is addition of two numbers here equal to 30, and x and y with a product means that which is x multiplied with y, okay, where the product is maximum. So we put this one here as a p equal to x multiplied with y. Okay, these two are information that we can straightly get it from the questions here. And then let's make this one as a y equal to 30 minus x. Okay. It makes equation 1, and also here equation 2. So we substitute equation 1 into an equation 2. So we put it here, p equal to x and y, which is now represented by the 30 minus x. 30 minus x, then we come up with 30x minus x squared. Okay, so this is a question that we're gonna use here now. P equal to 30x minus x squared. Then we derive or differentiate p respect to the x. Okay, so let's derive this one by one. 30 times 30x, differentiate this to give you 30, and then differentiate x squared minus 2x. Okay, from here let's make this one, I have dp dx, make it equal to 0. So then here now 30 minus 2x equal to 0, then negative 2x equal to negative 30, then x equal to negative 30 divided by negative 2 equal to 15. And now this is a value of x equal to 15 that we're gonna substitute into the second derivative of p respect to the x. But before that, we're gonna find out second derivative of p respect to the x. So this dp dx, the second derivative here. From here we derive, we come out with, okay, differentiate 30, 0. Differentiate negative 2x, come out with negative 2, which is less than 0. So clearly from here that it is a maximum, because the second derivative of p respect to the x, which is now we call negative numbers, which is less than 0, so it is maximum now. Okay, so then where p, which is maximum, with x equal to 15, then we substitute into then equation 1 here, x equal to 15 plus y equal to 30, then y equal to 30 minus 15 equal to 15. Okay, so the product is now we call two positive numbers with the sum 30, and the product is maximum product, which is x multiplied with y, so then x equal to 15, y 15. So this is a solution for question number 1. Question example 4. A cuboid had the following dimensions of length of 12 minus 5, breadth of x, and also height of 2 xcm. Calculate the maximum of the volume of the cuboid. Okay, so just imagine that if this is the cuboid here now, okay, so we get it here. Also, we go on the other side of this cuboid here then. Okay, then height is 2x, and this is an x, and here is 12 minus 5x. Okay, so V, or the volume for this cuboid for 3 dimensions then is, we know that is an V equal to x multiplied with 2x multiplied with 12 minus 5x. Okay, so we multiplied and simplified all this. 2x times x, 2x squared, and 2x squared times 12, 24x squared. And then x times 2x, 2x squared multiplied with negative 5x, then it gives you minus 10x cubed. Okay, then we find that we call derive dv, derive v respect to the x, means that we differentiate this one by one here. 2 times 24, 48x minus 30x squared. Okay, so let's make this one here. Let dv dx equal to 0. It means that we find out 48x minus 30x squared, make it equal to 0. Okay, so factorize this. 48, 6, 8x, and then 6 times 8 equal to 48 minus let's say we divide by 6. 6 times 6, 48, and minus 5x, make it equal to 0. So from here, it gives that x equal to 0. Okay, this one. And from 8 minus 5x, 8 minus 5x, make it equal to 0, then x equal to negative 8 divided by 5, then come up with 8 over 5. Okay, so this gives us the value of x, which is 8.8 over 5. Okay, are we going to accept both of this? X equal to 0. If x 0, meaning there is no side of this, we call this cuboid. 2 times x, there is no height of this cuboid. And for this one, might be length is 12, because 5 times x equal to 0. So this is not one of the answers. Okay, because x must be positive, because we wanted a value of x for this side here and also the height. So this is the only value of x. So now, with the first derivative, which is dv dx equal to 48x minus 30x squared, then second derivative, second derivative of v, the volume respect to the x, equal to 2 times 24, 48, sorry. Okay, 48, 2 times 24, 48, x 2 minus 1 equal to 1, 48x minus, v 24x squared minus 10x cubed, dv dx 48x, this one here, so second derivative should be derived from this one here, sorry. Okay, I make a mistake here, sorry for that. So derive or find out the second derivative. Second derivative means that we derive, we call differentiate from the first derivative here, 48x, they come up with 48, and minus 2 times 30 equal to 60x. And then we make it equal to 0 here. No. For second derivative, then we substitute x. Okay, once we found out the second derivative of this v respect to the x, 48 minus 60 times x, then we substitute this value of x into this value of x. So then, make it, when x equal to 8 over 5, with second derivative here, so then 48 minus 60 multiplied with 8 over 5. 60 divided by 5, 1, 12. 12 times 5 equal to 60. Then 12 minus 8, 48 minus 96. Okay. 48 minus 96, negative 48, which is less than 0, so then v maximum, v is a maximum, because we give you the maximum then. So for v maximums, it is equal to 8 over 5 here. So we substitute into this equation of v, x equal to, okay, x times 2x and 12 minus 5x. Substitute x equal to 8 over 5, 8 over 5 times 2 times 8 over 5, and 12 minus 5, 8 over 5. Okay, so then simplify this with 2 times 8 equal to 16, 5 divided by 5 equal to 1. Okay, we're referring to this equation. Actually, that we can use this too, but okay, if I substitute x equal to 8 over 5 into this equation, we're going to use this here now. Might be for some of you, can just substitute here and also here, still the same. Okay, because this equation from this here, okay, from the, you call the equation of this. Okay, now 8 over 5 multiplied with 16 over 5, 2 minus 12 minus 8 equal to 4. Okay, so then here now, it is 8 divided by 5 multiplied with 16 over 5 and multiply with 4. Okay. come up with this one here. 8 multiplied with 16 multiplied with 4 equal to 512 divided by 5 times 5 is 25. So then divide by 25 for this one here. It is almost equal 20.48 in the unit of centimeter. Okay, so now the first step here, we form the equation of this one, the breadth multiplied with the height and multiplied with the length here, 12 minus 5x, then we form the equation 24x squared minus 10x cubed. Then we derive for the first time, we find d by dx, 2 times 24 equal to 48x minus 10, 3 times 10 equal to 30x squared. And from here, we come up with d by dx, make it equal to 0. Then we find that it is, okay, from here, we factorize 8. I think that is supposedly 6, right? 6 times 8 equal to 48. It's not 8 here. 8 times 8 is 64. Sorry. Okay, supposedly 6. Okay. 6 times 8 equal to 48x. And then 6 times 5 equal to 30, negative 30. Okay, from here, from 6x, we make it equal to 0. 6x equal to 0. Okay, I make a recall line to separate between these two. Okay, 6x equal to 0, then x equal to 0, and from here, 8 minus 5x equal to 0, then x equal to 8 over 5. Okay, between these two, we only choose this one here because x cannot be equal to 0. If x equal to 0, just imagine that if this is 0, this is 0, means that there's no side here and there's no height. We only have the length. It's not a cuboid. Okay, so we need to consider everything before we decide what will be the, we call equation of the V here, volume. And then from here, once we have what we call derive for the first time, then we derive for the second time, find the second derivative of V with respect to the x. Okay, and then substitute the value of x equal to 8 over 5. We're not going to use a 0 here. Okay, so 8 over 5, then it is negative 48, which is less than 0. Then we come up with the conclusion that it is the volume is maximum. Then we substitute the value of x from we get here into the second into the equation of volume maximum here, because we have decided that this is the maximum from this equation. Then we substitute to find the value of V, we call the value of x, or the volume of V, which is 20.48 centimeter cube. Okay, it's a V. Okay, V, we call it the unit of centimeter cube, and x is 8 over 5 centimeter. Okay. Okay, a cone has a circular base with radius of r and the height of the cone is h. Given the slant height is 48, find the value of r and h if the volume cone to be maximized. So let's sketch the picture of the cone here. Okay. And we got the center of the cone, and this is the radius, and from the center of the cone to the peak of this one here is a 90 degree. And given to us the height of this one here, okay, the slant height. Okay, so from here is we can use we call the Pythagoras theorem of this with r square plus h square equal to this one here, which is square root of 48 from x square plus y square equal to z square. So z h squared here is a square root of 48. Okay, then from here now we clear this, then r square equal to 48 minus h square. Then the volume or formula of a volume for this cone is v equal to 1 over 3 pi r square h. Okay, and pi is not an unknown, okay, just like r or h, but pi is a unique value for that we're going to use into the formula of circle. Okay, so then here now look at this one, r square, and we also have r square here. So let's substitute the value, the equation of r square 48 minus h square into this r square. So then 1 over 3 pi r squared, which is 48 minus h squared multiplied with the h, and this one is going to give you 16 pi h minus 1 over 3 pi h cubed. 48 divided by 3 equal to 16 multiplied with the pi, and then also h here, and then 1 over 3 pi multiplied with h squared, and h 1 over 3 pi h cubed. So we are going to come up with find the dVdh, find the dVdh, then find the differentiate the v volume respect to the h. Okay, so then here h is unknown in this equation here now, so we derive 16 pi h power of 1, okay, bring up here, and then 1 minus 1 equal to 0, minus, okay, differentiate this, 3 bring up here, become 3 multiplied with 1 over 3, so 3 divided by 3 equal to 1 pi h squared. Okay, so 3 bring up here, 3 multiplied with 1 over 3 equal to 1 pi h, and 3 minus 1 equal to 2. So then make it this one here equal to 0. So then from here 16 pi minus pi h squared equal to 0. It's just like negative pi h squared equal to negative 16 pi, and divide by negative pi left and right. So then h equal to 16. Now h equal to plus minus 4. By the way, we are talking about h, which is height, and height cannot be negative. Okay, height cannot be negative, meaning here is only h equal to positive 4 and h equal to negative 4. Rejected. Okay, we reject this. Okay, we only take this one, h equal to positive 4, as our value for the height, and then we derive for second time dVdh equal to 16 pi minus pi h squared. Okay, I rewrite here v dVdh equal to 16 pi minus pi h squared. Then we derive again, find the second derivative of v respect to the h equal to 16 pi is a constant. Okay, there's no variable or unknown of h here, so derive this equal to 0 minus 2 pi h. Okay, So then we're going to substitute the value of h equal to 4 into here. So second derivative of v respect to the h, where h equal to 4. Okay, when h equal to 4, so second derivative of v respect to the h equal to negative 2 pi times 4, then it is equal to negative 8 pi. And this value is negative, which is less than 0, then v is maximum. Okay, v with the maximum when h equal to 4. Then let's find out now what is the value of r. What is the value of r when h equal to 4? Then here now r square equal to 48 minus v equal to 4 square, which is 48 minus 16 equal to 32. Then r equal to square root of 32. Square root of 32, let's simplify this, it gives you 4 square root of 2. Okay. Okay, what's the question it wants from us? Find the value of r and h if the volume of the cone to be maximized. So to be maximized, okay, when r equal to 4 square root of 2 and h equal to 4. Okay, so let's see the step one by one, and I hope all of you understood with my explanation for this example here. Okay, for the topic rate of change, objective to find related rate of change. Okay, so if y equal to fx, then dy dx is the rate of change, of y respect to the x. If rate of change of quantity means that the rate of change of q respect to the time of t. So it has been somehow correlated with physics because the changes of q and is subject with the time. Okay, if the rate of change is positive, means that the quantity is increasing with time, and if the rate of change is negative, means that the quantity is decreasing with time. Okay, a cube has a side of x cm. Estimate the rate of total surface area of cube as it is side increases at a rate of 5 cm per second when the side is 12. Okay, a cube. Okay, 3 dimension of a picture of box here, cube. A cube, you may also imagine that, imagine a dice. Okay, when I read here is x, height x, and also here is an x. So v for this one here is x multiplied with x and multiplied with x, and it gives you x cube. Okay, so a cube has x centimeter. This is the first information from the question. Estimate the rate of change. Estimate the rate of the total surface area. Okay, for this one here we rate in the total surface area. If I define this one as a dA dt, okay, rate of total rate has something to do with time, the total surface area of a cube, and the side increases at the rate of 5 cm per second. Okay, side increases at the rate of 5 cm per second. So for this one here, I define as an dx dt equal to 5 centimeter per second. Okay, where the side it is 12. Can we relate between these two and come up with one equation? Okay, so class, it is equal equation of dA dt equal to the record changes of the surface. No, okay, sorry then. So, a cube, if I imagine that, estimate the total surface area. Okay, class, side increase. Let's say if I open up this box, it's gonna be something like this. Okay, let's say there are, we call the side of the box. Okay, from here we have the first surface 1, 2, 3, and 4. 1, 2, 3, and 4. And that front here, and also the other side, which is, let's say, okay. So this is what we call the picture of the box. If we will open it up one by one side here, and then let's say if the side, if the x increase, if the side is increased at the rate of 5 centimeter per second, meaning that this side is getting bigger and bigger with this rate. Okay, you can just imagine it. If I come up with this one here, the changes of the surface respect to the x, when x is getting bigger, and then the surface of course change is getting bigger and bigger, the increase, and then with what we call respect to the time, then we come up with dA multiplied with dx. And because there are three things that we need to consider here, is the first thing is the total surface area. Okay, means that we're talking about the surface of this we call cube. Okay, A, and also side, the side which is x, x, and x here, at the rate of 5 centimeter per second. Then have to do with the time. So we are talking about the surface, we call the surface of the cube with the side of increase of x and also time. So it means that here we come up with dt and also dt. Given in the question here, dx dt, which is equal to 5, and then dv dx equal to 3x squared. Now let's substitute the information given here, dv dx dA, sorry. Okay, now class, I think that I don't realize that we're talking about the surface of area, but then I find out we call V, volume of this cube. Okay, so I make a mistake, I may make a correction here. So we got nothing to do with the V of volume for this case. But then, okay class, the surface, the area of this one, this, recall this here with an x and also x and x. Okay, so how many surface do we have? 1, 2, 3, 4, 5, and 6. So A equal to 6 box because 6 surface here, 1, 2, 3, 4, 5, 6, and every surface we mark calculation of this side of x multiplied with x, so 6x squared. Then dA dx equal to 12x. There you go. Okay, and then when the side is 12 centimeter, so with 12 times 12 equal to 144. Now we substitute dA dx into this equation, 144, and the question said estimate the rate of surface. Surface is an A, okay. Rate means that the changes respect to the time, then dA dt. And then dt dx. What we have here right now is dx dt. And what we need here right now is dt dx. So then from dx dt, then come up with dt dx, which is 1 over 5. Okay. Reciprocal of this one here, 1 over 5. It is now multiplied with 1 over 5. Now, this is the things that we need to find out here now. dA dt equal to times 5 here and also times with 5. Then 5 multiplied with 144 is equal to 720 centimeters square per second. Okay. So class, when this come up with a term of rate, increase at a rate, meaning that is a changes of something respect to the time. Rate, we have to call the changes of something, we have something S here, or respect to the time. A cylindrical tank has a base of radius 3 meter. The tank is filled with water at a rate of 4 meter cube per minute. Find the rate of change of water level in the tank. Cylindrical tank. Okay. Here. Sorry. Okay. Cylindrical tank. Then of course we're talking about the center of the circle here. Then there is a radius. Okay. And then with the height, so dV, a cylindrical tank has a base with a radius of 3. So then R equal to 3. Where here is R equal to 3. The tank is filled with the water at the rate of 4 meter cube per minute. The changes of volume respect to the time. dV dt equal to 4 meter cube per minute. Okay. But then before we find out the dV, okay, class, a tank is filled with that water at a rate of 4 meter cube per minute. Find the rate. A rate means that something, the changes of something respect to the time of change of water level. Water level in the tank. So it means that at one time, this is the water level. The tank is filled. Filled means that from the empty tank that we fill up water inside, and at one time, this is the water level. And after a few times, then we find that this is a water level, and so on. So the changes of from the bottom of this tank to this height h1, and then h2, and let's say here with H3. Okay, so the changes of this height respect to the time, but before that the changes are, but also the changes of the height, it gives you one volume of water inside the tank at one particular time. So means that here now we need to find out the volume of this cylindrical tank, which is pi r square h. Now, where r equal the radius 3 meter, so then pi with 3 square and h then come out with 9 pi and h. Then, because we are talking here now, the changes of height respect to the time, and also the changes of height, it give us a, and we call one value of volume inside the tank here. So the changes of volume respect to the h. Then it is now 9 pi. Okay, the changes of height, it gives you the changes of the volume of the water in the cylindrical tank with particular time, the changes of the time that here. So dV dH equal to dV and dH. So the changes of V respect to the time, and also the changes of time, that we call the H respect to the time here. So let's see what we given in the question here now. dV dH equal to 9 pi. Okay, and then dV dH is not given in the question here. Oh no, dV dt, the changes of volume respect to time, is not given in the question here. So this is the subject that we're going to find out later. And dV dt is given there. Sorry, I don't realize that. dV dt, the change of fill of water at a rate of 4 meter cube per minute. dV dt is given here, which is 4. Okay, and then dH dt is not given then. So then find the rate of change of water level in the tank. Is now, let's say, okay, now dt dH equal to divide by 4 here, and divide by 4, you come up with 9 pi divided by 4. Okay, find the rate of change of water level in the tank. So look at the question here. The rate respect to the time here of change of water level means that we're talking about the height. So dH dt is the answer, we call the things that we need to find out, we call as the answer here. So what we have here right now is dt dH, so then dH dt equal to 4 divided by 9 pi meter. Height with a meter, volume, meter cube, and minute, we call time with a minute here, meter per minute. Okay. Next, above figure shows a right circular cone with radius of 6 and height of 12, and oil is pumped into the tank with a fixed rate of 10 cm³ per second. Find the rate of change of height in the oil when the oil level is 5 cm deep. Okay. Now the radius is 6. Radius. This should be a diameter. Okay, so the radius from the center to the ring here is 6, and then the height is 12. And oil is pumped into the tank, means that it's an empty tank here right now, that we fill up the oil inside with a fixed rate of 10 centimeter cube per second. So this is the volume, 10 centimeter cube, and second means that we can form this into the we call equation of dV dt. Okay, dV dt, volume 10 centimeter cube, the unit here centimeter cube, and the second with respect to the time. Okay, and then find the rate of change of height. Rate of change of height, meaning that let's say this is the bottom of this tank, and if I fill the water until this level, okay, it has its own height. We name it as an H1. And until here, for example, then we define this as an H2, and so on. So the changes of the height will give you the changes of the volume inside this tank respect to the time. Okay, if I can come up with this one here, the changes of the height, then also give us the changes of the volume respect to the time. Okay, then it is now dH dt, no, the changes of the volume respect to the time. And now dV dt, the changes of volume respect to the time equal to dV and dt here. So there are three things that we need to consider. We call with the changes of the volume. Okay, changes of volume with the height respect to the time. So we are talking that here now is a dV dH and dH dt. Okay, so given in the question here, an oil pump tank into a fixed rate of 10 meter cube per second. So dV, the volume respect to time, is given here now. dV dH, okay, and then find the rate. Rate means has something to do with time of change of height. So dH dt is the thing that we need to find out the answers for this question here. But then for dV dH, meaning we need to find out the volume of this cone. V equal to 1/3 pi r square and h. Okay, and class, because it's a cylinder cone here, such a cone for this, the tank of this is a tank of this is a cone, meaning that at every single height, h1, it gives us the difference of radius r1. When it reach up until h2, then it's a difference of radius of r2. And let's say if I add another one here, this is the h3, then look at this radius. This radius is different from here and different from this, where r3 is greater than r2, greater than r1, and then on top of 6 here, of course, 6 is greater than r3. So there is a ratio of a radius to the height, where this one here, let's say the ratio of r and h equal to with 6 and 12, radius and 12 the height here. 6 of 12, which is 1/2, and r equal to half of the height. Okay, so then 1/3 pi r 1/2 h square, and multiply with the h, and now it gives you, okay, 2 square equal to 4 times 3 equals to 1/12 pi h square times h cube. Okay, then dv dh equal to 3 times 1 over 12 by h 3 minus 1, and this is going to give you 1 over 4 by h squared. And now let's rewrite our equation here, where dv dt equal to dv dh multiplied with dh dt. Okay, so the first information given in the question here, dv dt, which is 10 meter cubed per second, and dv dh. By the way, we already found out the dv dh, but then it's given then the change of height of the level, which is h, and also the time respect to the time here, when we call the height is 5 centimeter deep. So in this case, we come up with dv dh, when h equal to 5, then we come up with 1 over 4 by 5, h equal to 5 squared, which is 25 over 4 pi. Okay, again, dv dt equal to 10 here, and dv dh equal to 25 over 4 pi, and dh dt. So then, dh dt equal to 10 divided by 25 pi over 4, 10 divided by 25 pi over 4, or it is 10 multiplied with 4 divided by 25 pi. Okay, so from here, 10 with 25, 10 divided by 5 equal to 2, and 25 divided by 5 equal to 5. 2 times 4 equal to 8 divided by 5 pi centimeter per second. So the changes of height respect to the times, height centimeter and time second. Okay, that's all for today. Thank you very much, and good luck for your final examination to all my students. That's all. Again, Assalamualaikum warahmatullahi wabarakatuh, and have a nice day.